So for part A of this question, we've got to put two curves onto the same axes. The first one being y equals 1 over x. That's our standard reciprocal curve, which we should know looks like that. We've got asymptotes at the x and the y axes. And then we've got y equals x squared plus 6x plus 12. So that's going to be a U-shaped quadratic. Now it's not going to factorize, so let's just have a look at doing a bit of completed square on it. So we've got x plus 3 all squared minus 9 plus 12, so that's x plus 3 all squared plus 3, which tells me I've got a minimum point at minus 3, 3. So minus 3 there, 3 there. So we've got a minimum point there. And it's going through there at 12. So what's happening is we've got a curve doing something like that. Okay, so we've got our minimum point clearly identified and we've got our intercepts identified. There's my two curves. There's part A done. On we go to part B. It says using our sketch. So we're not going to do anything with this quadratic. We're not going to solve the quadratic. We're going to use the sketch, but we've got to justify how part A relates to part B. So if we go for x cubed plus 6x squared plus 12x minus 1 equals 0, let's move the 1 over. So we've got x cubed plus 6x squared plus 12x equals 1. Now divide the whole thing by x, so that gives us x squared plus 6x plus 12 equals 1 over x. So we can see that our original cubic there transforms into the two equations that we drew. So the number of roots will be determined by kind of how many roots we've got in our sketch. We can see the number of roots in our sketch. It intercepts in one place there. So we can say 1 root since 1 point of intersection. So what we've got there is a justification of our answer.